Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover the mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. So, the first unit is about the mobile networks. The outline of the lecture series 1 is introduction to GSM and mobile services offered by the GSM. Basically, the GSM has replaced the first generation analog systems. So, how the systems are replaced and why should we found this GSM network? So, all the things we are going to learn in the subsequent chapters. The mobile services offered by the GSM, it has its 3 classifications like bearer services, tele services, and supplementary services. Before learning the GSM architecture and all, it is mandatory to learn about introduction behind the GSM architecture. As we mentioned already, the GSM is a second generation telecommunication system. It replaced the first generation analog system. The first generation analog system was covered all the analog telecommunication systems, but fortunately we have found the next one, that is the GSM. It belongs to the second generation. It is a successful digital mobile telecommunication system. The main goal of the GSM is to provide a mobility. So, the users was able to move while the call is established. So, that we have found the mobility. Primary goal of the GSM is to provide the mobility, and providing the data as well as the voice is the main goal while providing the mobility to the users. But when compared with the third generation systems, the performance of the second generation, especially the GSM, is somewhat less, because the data speed, the data rate and everything, when compared with the third generation, the speed is somewhat less. Initially, the GSM has been deployed in Europe countries with various frequency ranges. For example, when they developed the first GSM in Europe, they allocated 890 to 915 megahertz for uplink frequencies and 935 to 960 megahertz for downlink frequencies. They have mentioned this standard as GSM 900. We should understand one thing, that the GSM has various flavors or various versions based on the frequency allocated. So, as I already mentioned, the GSM has various versions like GSM 900, GSM 1800 and GSM 1900. So, let us have a look at the various versions of the GSM versions. First, the GSM 900 is deployed in Europe country with a very good successful rate, and many users has enjoyed the facilities provided by the GSM 900. Here the uplink is 890 to 915 megahertz, and the downlink provides with the 935 to 960. What is an uplink? So the uplink is a channel which is established from the mobile station to the communication tower. So the users should be able to provide some information to the network, or they may try to make a call and all, so that uplink channel should be established. But the downlink is nothing but the channel which is established from the tower to the mobile station, so that it is referred as a downlink. One of the flavor of GSM is DCS. It is also referred as GSM 1800 or 1800. Here the uplink is about 1710 to 1785 megahertz of uplink, and the downlink covers the frequency range 1805 to 1880 megahertz downlink. So we should understand one thing behind the GSM architecture. The GSM supports the frequency reuse. So the same frequency can be reused within the same network with the help of the concept of frequency reuse. So it adds the scalability to the GSM network. And the personal communication service, that is the PCS, also a version of GSM. It covers the uplink with a range of 1850 to 1910 megahertz, and for the downlink the PCS 1900 allocates 1930 to 1990 megahertz. And one more very interesting and very attracting versions of GSM is GSM Rail. It is also referred as GSM R. This system is developed and used and deployed in the European countries mainly for railroad systems. Majority of the features offered by this GSM R is not offered for the public GSM network like GSM 800 or GSM 900, because it has a very special features only for railway communication systems. It offers 19 exclusive channels for railroad operators, so that rail engine drivers, they can communicate with the control rooms using these channels. So they are entirely dedicated only for the railroad operations. So the users here, the control room operators or the rail engine drivers, they can communicate, they can send the data using the 19 exclusive channels. It was a very great successful version of a GSM. So some of the very attractive feature of GSM is emergency calls with acknowledgements. If there is any accident, the driver can make a call, or the control persons from the control room, they can send some information to the train drivers, so that the emergency calls are available, and the emergency calling system is supported by the GSM R, and they can broadcast the voice also, that is referred as VBS. So here one thing we have to note down is the calls are prioritized. The high priority calls are preempt the low call. So we should understand what is the priority of a call. During the normal call, the users will be allocated with a channel, so that they can make a call or they can send information through SMS, EMS alike. But something we should understand behind the emergency calls. So always the emergency calls, they got a very high priority. The preempting feature is supported by the GSM R. What is a preempting? So just to consider a scenario, normal users, they are using the available channels. So the channel is established between the users and the towers and all. But unfortunately, the control room need to send some very important information to the train engine drivers. At the time, the call which is generated in the control room, it will get a very high priority. But at the same time, there is no channels to be established. This is the point. The GSM R will preempt all the low priority calls. So all the channels allocated to the low priority users will be preempted, and that channels will be established for the high priority control channels. So this is a very interesting and very important features to be noted on GSM R. It supports the emergency call supporting systems. The setup time also very less when compared with the normal users. For example, the emergency calls can be made within 2 seconds, and even for the group calls less than 5 seconds the calls can be established. the calls can be directed to all users at a certain location. For example, all the drivers, they are driving the trains in a particular location. So the emergency information will be delivered to all the users with the same period of time, and also the users with some certain functions can be notified. For example, in a particular location we can assume that we have 100 or 20 engines, but the control room wants to send one particular information to a set of drivers. For example, we can assume that the drivers of the 10 train engines. So the particular subset within the location also can be reached using this facility. The most sophisticated use of the GSMR is the control of trains. So that the drivers itself, they can control the trains, other trains, and the switches and gates and signals. Also the control room also can control all the things. So it is the very sophisticated feature provided by the GSMR. So GSMR provides a constraint that the trains, they are running less than 160 kilometer per hour can only use these facilities. So they can control the gates, switches and signals. So there is a question, what about the trains running beyond the speed 160 kilometer? That we will discuss later. So far we have discussed some very important basics about the GSM and all. So why should we go for the GSM, and what is the purpose of developing the GSM and all, that we have covered. And now we are going to see the mobile services offered by the GSM. So GSM basically offers three type of mobile services. First one is bearer services, second one is tele services, and third one is supplementary services. Now we are going to look in detail about the three type of services offered by the GSM mobile services. Very talented feature of the GSM is it enables its users to interoperate with the existing system. For any system, it may be a good or it may be a bad system, first requirement should be the interoperability. To launch a new system, we cannot replace all the existing systems. So the GSM specification was very clear about this point. So they developed this, their own systems by keeping the point that it should be the interoperable one with all the existing networks. So the voice and data services of the existing networks can be integrated with the GSM users. This is the main reason for the great success of the GSM. GSM has defined the three different categories of the services, and how the integration of various kind of systems is possible with the GSM, that we are going to see. A mobile station is nothing but a mobile phone. A user has their own mobile phone, they can roam around. So the mobility is supported by the GSM. Now the mobile station is connected to the GSM public land mobile network, that is referred as PLMN, with the UM interface. So the UM interface is the point or a set of specifications that specifies how an user is connected, or how an user should be connected, or how many number of users can be connected with the same time with a single tower. So the UM interface plays a very important and vital role in the specification of GSM mobile service. Now the PLMN is the infrastructure, the backbone infrastructure which is required for the GSM network. So we can say that the GSM is running on its own infrastructure. Let us have a short break. After the break, we can continue from the reference model of the GSM services. Welcome back. We were discussing about the introduction about GSM, and we have started the discussion about the reference model. Now let us have a deep look at the reference model of the GSM services, so that we can understand how the GSM systems are running. The bearer services and tele services and supplementary services are noted in the diagram. First, the mobile station is connected with the GSM PLMN network. The GSM PLMN network is connected with the transit network, that is a mandatory network, or we can say that this is an existing network, already deployed network, and obviously we need the source and destination network so that other users to whom we want to communicate, they are connected with the source and destination network, and obviously they have their own terminal equipment. So, terminal equipment is nothing but the mobile kit of the users. Now, the mobile station is consisting of the two important parts, one is terminal equipment and one is mobile station. Now, the mobile station is responsible for all the operations, that it says how the user is connected with the tower. So, the interface plays a very vital role. It specifies the set of rules how the mobile users are connected with the network. Here we can note down some other interfaces like USR. These are the interfaces defined by the source and destination network. Now, the GSM PLMN is the backbone of the GSM network. The GSM network is connected to the existing transit network, that is the already deployed network. The very famous and successful deployed networks are ISDN and PSDN, that is the public switched telephone networks. They have their own number of users. So, now the GSM wants to provide or extend its services to the existing users. That is a major reason for the grand success of GSM. So, as I already mentioned, there should be a source and destination network before another terminal is connected to the GSM users. Among the three services provided by the mobile services of GSM, the bearer services only need to the communication with the low layer or lower layer of the ISO OSI reference model. The lower three layers are nothing but the physical layer, the network layer, the data link layer. The physical layer says about the encoding schemes and signal representations. So, it specifies how the signal should be transmitted. So, obviously here the GSM system has to take care about the wireless signals, because the users are connected through the air medium with the tower, and the next medium is data link layer. That data link layer specifies how to handle the flow and error control, these kind of mechanisms. And the third layer of the OSI layer is nothing but our network layer, that specifies how to reach a system in the network. So, now the mobile termination, the user's equipment, it covers all the operations. It takes care about all the operations like TDMA, FTMA, that is how to share the time division multiplexes, frequency division multiplexes and code division multiplexes. So, all kind of operations are taken care by the mobile termination. Mobile termination offers an interface for data transmission to the network independent terminal, that is the other user. One fact about the GSM is the initial or the original GSM specification supports the data rates up to 9600 bits per second for the non-voice services. The bearer services itself supports the transparent, non-transparent, synchronous and asynchronous data transmissions. We will see what is the transparent and the other services supported by the bearer services. As we already mentioned, the transparent bearer service is responsible for taking all the functions of the physical layer of the OSI model. So, how to transmit, how to represent the signal. So, all the things are taken care by the transparent bearer service. GSM uses forward error correction methodology or mechanism to support the very high transmission quality. For example, if a particular data is missed, so the forward error correction mechanism can be used to retrieve all the data, because that is a redundant data. The data transmission has a constant delay and throughput, provided the transmission errors should be very low. The transparent bearer services do not try to recover the lost data, it will try to repeat the data. Non-transparent bearer services use the protocols of the layer 2. Obviously, the layer 2 is nothing but the data link layer as well as the layer 3, that is a network layer, to implement the error control and the flow control. Error correction, error control, flow control, these are all the major requirements to any network. Radio link protocol, that is RLP and HTLC, are combinedly used in the non-transparent service to provide the flow control, so that this RLP will trigger the retransmission in case of the error transmission. The throughput and delay is mainly depending on the transmission quality. For the very high transmission quality, the delay will be obviously very high. Using the transparent and non-transparent services, GSM specifies several bearer services for inter-networking with the PSDN, ISDN, that is the worldwide deployed networks. So far we have discussed about the bearer services provided by the GSM. Now let us discuss about the tele services provided by the GSM. GSM mainly focuses on voice oriented tele services. It also supports the data services. The main service is telephony, that is to provide a very high quality digital voice data transmission. This voice service is offered with a typical bandwidth of 3.1 kilohertz of analog phone systems. Special codecs are used for providing the very high quality voice transmission in GSM. When compared with the other codecs used in the other networks, particularly for the analog systems, their quality is somewhat less when compared with the GSM codecs. So, the traditional computer modems using other codecs can be interoperated with the special codecs supported by the GSM. Another very important service supported by the GSM is emergency number system or emergency number service. In case this service is mandatory for all the providers and it should be a free of charge. So, this is the mandatory service that should be provided by the GSM service providers. We can compare this to the GSM R versions because the calls established using the emergency service system has the very highest priority, and it also has the capability of preempting other connections, and automatically the calls will be set with the very closest emergency center. The governments normally insisting all the service providers to implement this kind of emergency services. The very attractive feature of the tele services supported by the GSM is the SMS. As we know, the SMS offers the transmission range of 160 characters. SMS messages normally they won't use the data channels of the GSM because the data channels are very scarce resource, very emergency numbers, and that call should be established with the channels. So, GSM does one special technique that GSM exploit the unused capacity in the signaling. So, the unused control channels are normally used for SMS transmission, and sending and receiving of the SMS is possible during data or voice transmission. That is, even if an user is engaged with some call, the user can receive the SMS. And one more interesting fact about SMS is when the SMS was started, no one was interested with the SMS facility, but in the middle of 90s, all the young people, they have only discovered the very interesting facts about the SMS services. SMS is used for many applications like sending the star codes to the users and displaying the road conditions like. So, almost the SMS is the very big business for both network operators as well as the content providers. SMS is one of the typical way to reach a mobile phone from within the network. So, the network systems, they can send the SMS to find out the users within the network. Also, SMS is used for updating the mobile phone softwares, for implementing push services. The successor of SMS is Enhanced Message Service, EMS. The EMS offers larger message size. For example, up to 760 characters it supports. It can concatenate several SMSs together, the formatted text like. The transmission of animated pictures, small images, ringtones are possible with the help of EMS service. The teleservice of GSM also provides the multimedia message service, very attractive features. MMS offers the transmission of larger pictures like GIF and JPG files and short video clips, etc. And another one very important non-voice teleservice that is supported by the GSM is fax. In this service, the fax data can be transmitted as a digital data. That is a very attractive feature of the GSM teleservice. So, that fax data can be transmitted through the analog telephone, that is the existing network, through the modems. So, the transparent fax service is especially used. So, the fax data and fax signaling is transmitted using the transparent bearer service. Now, the user can understand the relationship between the transparent bearer services with the fax. Now, let us have a look at the summary of today's lecture. GSM is a 2G digital mobile telecommunication system. It replaced the first generation analog system. GSM comes in many flavors like GSM 900, GSM 1800, GSM rail, etc. These are classified based on the frequencies allocated to the uplink and downlink channels. GSM specifies the standard interfaces like UM interface, O, A and A bits as we have seen in the reference model. GSM offers SMS, EMS, MMS services. Let us put some questions for our understanding. What is the main goals of GSM? Is emergency number service mandatory in GSM? Can two mobile phones transfer data without GSM infrastructure? What is a full duplex channel? What is a call preemption? With this, we can conclude today's lectures. In the next lectures, we can cover the supplementary services of GSM and the system architecture of the GSM. Thank you.